Thank you ladies and gentlemen for joining us tonight for yet another exciting round of our presidential candidate debates. I'm your host, famous mathematician, Dr. Statistics. I'd like to start on education. Let's talk statistics. Please describe to the audience just what is your position on the need for statistical significance.
Well, doctor, when preparing a statistical test, one always has at least two hypotheses. There's always a null hypothesis, which is the assumption that the categorical variables have no relationship. Then there is at least one alternative hypothesis, which is the assumption that the variables have a relationship. In order to achieve statistical significance, the resulting p-value of the test must be small enough so that we reject the null hypothesis and accept the alternative hypothesis.
I agree with Romney. But I'd like to break down the p-value for my fellow non-mathematical Americans. It represents the probability of an unusual result from a relationship between two measurable variables. With p-values, we're not working with continuous variables. When running a statistical test, we chose a margin, a p-value, to compare to our results. We then have the numerical expression of the p-value in our results of a statistical test that determines statistical significance. Right? This resulting p-value is then compared to the marginal value. The generally accepted p-value is no larger than 0.05, or 5% error. It is our marginal value for what is the expected normal result of a test. If you will, it is our statistical security guard. Think of it this way: if you are bigger than the security, he will not let you be significant. If your p-value is larger than the 0.05, you will not, I repeat, you will not have statistically significant data. You may have a tendency to show, but it is not significant.
I would like to add that EBMS 05 policy is generally accepted, but it is arbitrary. For more accurate results, one can also use P01, P001, and P is less than 001.
I appreciate both of your descriptions and how you work together there. I think we can agree, although p-value has its flaws, it's a necessity for statistics. And to clarify for the audience, a statistical test that yields a p-value would be like a correlation, ANOVA, one-sample t-test, independent samples t-test, paired samples t-test. Thank you candidates for your time, and I hope our voters and fellow statisticians are better informed in light of this debate.